Recording in progress. Hello everyone. In this video we're going to be doing some examples of finding all of these things. So degree, number of turning points, zeros, positive, negative intervals, increasing and decreasing, and domain and range. Whenever I say number of turning points, what I really mean is max and minimums. Maximums and minimums. So just keep that in mind whenever we do talk about turning points, that you could also use those values thinking about it. All right, so let's start with the first one, and we're going to start out with the degree. All right, and the degree for this is just going to be the highest exponent, and the highest exponent on this is going to be 5. So the degree of this function is 5. All right, now talking about the the number of turning points. We're actually going to type this into Desmos, and the reason is the maximum number of turning points is going to be 4 because it's 1 less than the degree. But the maximum might not necessarily be how many turning points there are. So let's go type this into Desmos. We're going to see how many maximum and minimum points there are. X to the 5th minus 2x to the 3rd. Okay, and I just want to look, how many times does this go from increasing to decreasing? Making like either a little cup there or a mountain in the other direction. So I want it to either be a maximum or minimum. So here's a maximum point. Right? So it goes increasing to decreasing, that's maximum. Then here it's going decreasing, still decreasing, that one doesn't work out. But this one here is going decreasing to increasing. So this is another turning point right there, going from decreasing to increasing, that would be a minimum point there. So there are actually only 2 turning points that could happen, but you see that if these were pulled down a little bit more like that, you would have 4 turning points. But in this case, we only have 2 turning points, 1, 2. All right, so this one has 2 turning points. All right, then for the number of zeros, all right, that's just going to be how many times it crosses the x-axis. So we're just looking at x-intercepts here, nothing else. So let's go look at the x-intercepts. That's happening 1, 2, 3 times. And again, usually the number of zeros is going to be the same as the degree there, but we do have some imaginary values that are happening here and here on our graph. Or actually, sorry, we don't have imaginary values because this is a cubic, and really this is a multiplicity of 3 on the zero. So 1, 2, 3, 4, 5 is what's happening here because you have the cubic looking function going through there. All right, so there are 1, 2, 3 zeros. Oops. All right, there are 3 zeros. And 1 has a multiplicity of 3. At 0, multiplicity of 3. And that's because there the graph looked like this at the 0. And that's what a cubic looks like, so something like that. All right, so let's go on to the positive and negative intervals. So we're going to start with positive. So where is the graph above the x-axis? All right, so let's go back. And we can see that the graph is above the x-axis between here and here. See, it's all up above, but then afterwards, it's all going to be almost all of it is going to be below from here to here. So we see that it is above the x-axis here, then it goes below, and then it goes back above. So above is going to be from negative 1.414 to 0, and we're only looking at the x values. And it's happening again after that, so 1.414 to positive infinity, because after that, forever, it's going to be above the x-axis. So you can see this is all positive here. Okay, so let's go back and to infinity. All right, then for the negative intervals, all right, let's go back. This is going to be when it's below the x-axis. So you can see all the way down here. So from negative infinity until negative 1.414. And then it's happening again between 0 and 1.114. 414. So right here, it's going below the axis. That's also going to be our negative interval. Okay, and what should happen is exactly what's happening here. You can see that from negative infinity to negative 1.414, then it starts again with the positive to 0, then negative, and then positive like that. So everything should be like filling in the gaps of the intervals there. All right, so now let's look at increasing and decreasing. All right, so this function is increasing. That's going to be imagining that you're on a roller coaster. So coming up right here, increasing all the way from negative infinity up until this point right there. So from negative infinity until negative 1.095. And we're only using the x values. Then it's decreasing, decreasing, and then it starts increasing again after this point right here. So from 1.095 all the way to positive infinity. All right, so now let's do our decreasing, and then we're going to do our domain and range. All right, so our decreasing interval, there's really only one place where it's decreasing, and that is from this point right here all the way down to this one. So from negative 0.095 to positive 1.095. Okay, negative 1.095 to 1.095. Okay, then we're going to do our domain and range. So let's start with our domain. And what you're going to find is that for all polynomials, they're going to have the exact same domain because everywhere on this x-axis, there are points that exist. So the further out that I go, this function is still existing, even though it takes a really long time to get over here to negative 1,000. It will eventually happen because this is a polynomial, and there's not a point that is being restricted in the domain. So this is going to have a domain of negative infinity to positive infinity. And then my range, you can see this function exists all the way down in negative infinity on the y-axis, and it's existing all the way up into positive infinity on the y-axis. So this function is existing in both directions from negative infinity to positive infinity. Okay, so let's try out another example. Let's box our answer here. Okay, so this second one, we're looking at this function right here. So let's start with our degree. And that's just going to be the highest exponent. So the degree on this one is going to be 4 because it was the highest exponent there. So now let's look at the turning points. All right, and we're just going to go to Desmos and type this in, see how many maximum and minimum values we have. Okay, so here's our function. You can see it's going from decreasing or increasing to decreasing, so there's one maximum. Then it goes decreasing to increasing, so there's a minimum. And then all the way up here, it's going from increasing to decreasing. So there are only 3 turning points here, and this actually does match because it's supposed to be 1 less than the degree. So it was 4, and there are 3 turning points here. 3 turning points. All right, now let's look at the zeros. That's where it's crossing the x-axis. All right, and it's crossing the x-axis 1, 2 times. And then we're actually going to have some imaginary zeros here because this is like floating. But if we push that upwards, you would see that there were zeros there. So anyway, we only have 2 zeros in this function, right here and right here. Okay, now we need to look at our positive and negative intervals. All right, so positive, that's where it's above the x-axis. So let's go look at that. And we can see that this one is above the x-axis from here until here. That's whenever it's above the x-axis. We only want to look above. So this is from 0.681 to 2.065. All right, now we want to look at our negative interval. And again, this should kind of fill in the gaps. So let's go look. You can see that it is below the x-axis from negative infinity, because all the way over here, until this point right here. So from negative infinity until 0.0681, or sorry, 0.681, it's going to be negative. And then it's going to happen again over here after this point. So it goes from above the x-axis to below the x-axis. So 2.065 all the way until positive infinity. A lot of people like to say negative infinity, but remember we're looking at the x-axis, we're looking at time, and this is positive infinity over here. So from 2.065 to positive infinity. Okay, let's go look at the increasing now. All right, and this function was increasing from negative infinity up until this point right here, which is negative 1.267. So from negative infinity to negative 1.267, it was increasing. Then it's decreasing from here to here. Then it's increasing again from here until up here. So from negative 0.259 to 1.526 is increasing. All right, from here to here. And now we're going to look at our decreasing intervals. All right, our decreasing intervals. Okay, so this first one, it was increasing, then decreasing here. So from negative 1.267 until negative 0.259. Okay, then it's increasing, and then it increases again from 1.526 all the way until positive infinity. So from 1.526 to positive infinity. All right, so let's look at our domain and range now. All right, and the domain is always going to be the same. It's going to be negative infinity to positive infinity. So let's go look at the range. Okay, and we just want to see what y values this can possibly have. So looking on the y-axis, I can see this exists all the way down to negative infinity. Okay, it's always going to exist there. So let's go look at positive infinity. Okay, it's existing, it's existing, it's existing, and now it doesn't exist anymore, right? It just stopped. And where it stopped was right here at this point, and we only want to look at the y value because the range is our y value. So from negative infinity to 3.944. 3.944. And because that point exists, there's not a hole there, we're going to put a bracket on that point. The reason that we haven't been using brackets before is because we're talking about intervals. So with an interval, we're not going to use a bracket, we're only going to use parentheses. Okay, I'm actually going to stop the video here. I'm going to break it up into chunks. So the next video will be on examples 3 and 4. Have a great rest of your day. Goodbye.